Here we go, AB kids. We are on number 5. I've already started some work to shorten this video out. So we need to find the derivative at all 9 of those points. I've already done it for, let me highlight, at -1, 2, at -1, 1, at -1, 0, 1, 2, 1, 1, and 1, 0. So now I just have to do 3 more. I'll do it down here. So again, I need to restart my iPad because it's doing weird stuff. That's me doing weird stuff. Here we go. X, Y, and we're going to do 2, 2. That's going to be this point right there is 2, 2. So in our function that's given right here, we're going to plug in 2, 2. So it's going to be 2 minus 1 over 2 squared. And then we're going to find it at 2, 1. And that's this point here. And we plug that in. That would be a 0. And one more point. And that's going to be 2, 0, which is clearly that point. This will be pretty easy. All right, so the next step is to draw those slopes at those points. So if we look at the first one I did, -1, 2, the slope is 1. So you want to draw something with about a 45-degree angle at -1, 2. -1, 1, 0, the slope is 0. So we draw a slope is 0. And at -1, 0, the slope's -1. So we just draw a -45-degree slope. Then we're going to look at the next 3 I did prior to coming on. That's at -1, 2. -1, 2, the slope is 1. So again, I draw something with about a 45-degree angle. -1, 1, I found the slope 0. At at 1, 0, the slope was -1. So again, a negative 45-degree. Then the 3 that I found with you, at 2, 2, the slope was 1/4. Now it's hard to draw a slope of 1/4, so basically you just need something pretty flat. Clearly bigger than 0, but smaller than 1. The 0 is pretty easy. And the last point, 2, 0, is -1/4. So again, just something with a small negative slope. It doesn't have to be perfect. And that is the end of question number 1. All right, part B. Let me erase all of this. Some reason it's not letting me erase all those points. So again, those of you with OCD or CDO, I apologize, but they ain't going anywhere. They're stuck. So part B, we want to find a solution to y equals f of x. So we have the derivative, but we don't have actual f of x. So we're going to have to integrate. So we're going to start with our original function. Okay, here's our problem. Our variable is x, and our function is y. And here we have the function and a variable in our equation. So we're not going to be able to do straight integration. We have to do separation of variables. So we need to get everything with a y on the left and everything with an x on the right. So let's do some hocus pocus, and we end up with now we need to integrate both sides. Now the left side is a u sub. For you that are more advanced, you can see that du is just dy. So we end up with du over u, which is ln of absolute u, which is y minus 1. Now again, you can skip all that u sub if you recognize that since du is just dy, you could just automatically go directly to ln absolute y minus 1, but that's what's actually going on. The right side, we have to rewrite this, and then we add 1 to our exponent and divide by that. Don't forget our plus c, and I'll rewrite this like that. All right, let me see. So our next goal is to isolate y, but the problem is we have the ln. So to get rid of the ln, we can do this. I will do e raised to the left side and e to the right side, and the left side simplifies nicely to that. The right side becomes that. Now you need to know your rules of exponents. I can rewrite this. That's ugly. Remember, when you're multiplying exponents to the same base, you add the exponents. So going backwards, we end up multiplying that. Now, the absolute value, we need to deal with that. So let me give you a way of thinking about this. Let me do it in purple. If we had the absolute value of x is 2, clearly x could be plus or minus 2. So when we get rid of the absolute value, we need a plus or minus. And so in our original, if I get rid of the absolute value, I need a plus or minus. Now I'm going to rewrite this. Now, all of that is a constant. So we're going to rename that constant. We're going to let k be equal to plus or minus e to the c. So here's what we get. Now, I could play with the exponent of negative 1 over x and do some things with that, but we're going to leave that there. And at this point, we need to solve for that constant k. We were given the initial condition right there. So what we're going to do, we're going to use the point 2, 0. That is a solution. So when I plug it in to my equation that I have right here, so I'm going to plug that point into there. It must be equal because it is a solution. So I get 0 minus 1 equals k e to the negative 1 over 2. So I'm going to divide both sides by e to the negative 1/2. And I'm going to move the e to the negative 1/2 to the top, and the exponent will change signs. So now I have found my k. I'm going to plug that into my equation. Let's see. A green arrow looks fine. And that will get me this. Whoa, it's doing it again. I'm going to add 1 to both sides. Now, again, I can use my rules of exponents, and since I'm multiplying two exponents with the same base, I just add the exponents. And I get that beautiful answer. Oh, yeah, let me put a nice, what color do we want? I guess white would be bad. How about that one? I like that one. There's my answer. All right, we'll jump right to part T. We'll have part T. For the particular solution, so our answer that we just received, we're going to find the limit as x goes to infinity. So we're going to do part C. The limit as x goes to infinity of 1 minus e to the 1/2 minus 1 over x. Well, we should know that 1 over a number approaching infinity approaches 0. So that is simply 1 minus e to the 1/2 minus 0, which is just that answer there. All right, that's the end of question number 5. One more to go, and then I still have 2009. So I'm getting tired. Hope you guys aren't getting tired of watching these. We're prepping for the AP test. It will still be given to you guys, quite possibly at home. I'm not sure how that all works, but that's what I hear. All right, hope you guys are having a great day, and hopefully I see you guys soon. Bye.